All right, moving on to the next question. It says find the domain. And again, in this example, guys, we're going to want to look at the graphical approach to understand them. So let's go ahead and graph x squared minus 4. So x squared minus 4, 1, 2, 3, 4. And let's see, that's going to cross at 1, 2, 3, 4. 1, 2, 3, 4. So understanding my shape of a quadratic, I know it goes over 1, up 1, over 1, up 1, and then over 2, up 4. So actually it's going to cross at positive 2, negative 2. There we go. Okay. Oh yeah, positive 2, negative 2. And again, you could find your solutions by the graph if you aren't sure if I did that right. Just set x squared minus 4 equal to 0. And then you can say x equals plus or minus 2, right? Those are the x-intercepts, the solutions to the graph. Now let's go ahead and do, so that was the graph y is equal to x squared minus 4. And now let's go into the other graph, which would be y is equal to 9 minus x squared, which is probably easier to graph as a negative x squared plus 9. All right, and if we do the same thing, set the negative x squared plus 9 equal to 0, you can see x is going to equal plus or minus 3. But now this one is opening down, right? So 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right, so hopefully we have these graphs complete. So therefore you kind of have a basic understanding of at least what the two graphs are. Now the reason why I wanted to provide these two graphs is because we need to understand the restrictions here of our domain. So or of our domain for this function. So we have basically 3 restrictions that are going on. At least in this class, or at least in this kind of unit, we talked about you can't take the square root of a negative number. So we have a square root in the numerator and we have a square root in the denominator. We cannot take the square root of a negative number. That means everything that's under the radical, known as the radicand, has to be greater than or equal to 0. But we have another issue. We have a denominator, and we know that the denominator cannot equal 0. So in this example, so for instance, let's do the first one. So since we can't take the square root of a negative number, we know that x squared minus 4 has to be greater than or equal to 0. That's it. It has to be positive, but it can equal 0. There's nothing wrong with the square root of 0 is 0. However, we can't do that for the bottom radical because if it's equal to 0, that means the denominator is equal to 0, and that's an undefined value. We can't divide by 0. So therefore, what we're going to do for the denominator, or the radicand in the denominator, is just set it to greater than 0. Now, we don't want to solve these algebraically. What we're going to want to do is look at the graphs. So in this case, we're looking for what values is the graph larger than 0. So here's the x squared minus 4. Which values is x squared minus 4 greater than or equal to 0? And you can see here that this is going to be greater than or equal to 0. That means it's above the x-axis for, let's write this out, from negative infinity to 2. Actually, you know what? Let's do a number line. So this one, so here's negative 2 and here's positive 2. Okay, so it can equal negative 2 and it can equal positive 2. But anything to the below negative 2 or above positive 2, right, is going to be above the x-axis. Now, if I go ahead and do that with my 9 minus x squared, I say, well, when is that greater than 0? Well, that's greater than 0 for any number larger or for any number to the right of negative 3 and to the left of negative 3. So that one's going to look at, let's see, here's negative 3. Here's positive 3. But again, those are open circles, and it's all values in between, right? So now basically what we're going to do to identify the domain is we're just going to put these two graphs on top of each other and identify the intersection. So let's have negative 2, 0, 2, and let's do 3, negative 3. So you can see here, we have there, open circle, open circle. Okay, and again, we're only going to graph the where they intersect. So that's going to be between negative 3 and 2, and between 2 and 3. That's it. So to write that domain and using interval notation is going to be from negative 3 to negative 2, intersect, union, 2 to 3. And there you go, ladies and gentlemen. That is how to work. So that's a good question. I never Actually, I haven't done one of those in my class, so that's a good